Imagine looking down into a hole that has no visible bottom. No lights, no walls narrowing in the distance, just a perfectly straight opening running through the crust, the mantle, the core, and out the other side of Earth. If you fell in, where would you go? The simple answer sounds almost peaceful. Gravity would pull you downward. You would accelerate toward the center of the planet, pass through it, and begin rising toward the opposite side. In the cleanest version of the thought experiment, the tunnel contains no air. Earth does not rotate, there is no friction, and the walls somehow survive the heat and pressure. Under those impossible conditions, you could cross the entire planet in roughly 38 minutes. You would not keep accelerating the whole way. At the surface, nearly all of Earth's mass is beneath you, pulling you inward. But as you descend, more of that mass begins surrounding you. The layers above your position pull in different directions and mostly cancel one another out. Only the mass closer to the center continues pulling you deeper. By the time you reach the exact center, gravity would fall to zero. Not because Earth has stopped pulling on you, but because it would be pulling you equally in every direction. You would pass through that point at your highest speed, then begin slowing as gravity pulled you back toward the center from behind. If nothing took energy away from you, you would rise almost exactly to the opening on the opposite side, and then fall back again. You could continue moving through Earth like a pendulum, crossing the center over and over. That is the version usually described in classrooms. A real hole would be nothing like it. The first problem is Earth's rotation. Standing still at the equator, you are already moving roughly east at 1600 kilometers per hour because the planet is turning beneath you. When you fall inward, the tunnel wall moves around the planet at a different speed than you do. Unless the hole ran directly from the North Pole to the South Pole, or was specially shaped to account for the rotation, you would drift sideways and strike the wall. You would not fall cleanly through the center. You would scrape against the tunnel while moving faster and faster into conditions no material could survive. The second problem is pressure. Earth's crust is only a thin shell compared with everything below it. Beneath the crust lies almost 2,900 kilometers of hot, dense mantle rock. The mantle is not a giant underground ocean of lava. Most of it is solid rock, but under extreme heat and pressure, it can slowly deform and flow over geological time. Any empty tunnel bored through it would be surrounded by material under enormous pressure. The walls would not simply crack, they would close. Rock would push inward, deform, melt, and collapse into the opening. The deeper the hole went, the faster the planet would begin sealing it. Then, there is the core. Earth's outer core is a layer of liquid iron and nickel. Deeper still, the inner core remains solid despite temperatures comparable to the surface of the sun because the pressure is so intense. No known structure could hold open a passage through those layers. But suppose the hole was created by something impossible, a material that could not melt, bend, or collapse. Now the tunnel survives. You still would not. The hole is open to the atmosphere. Air would begin falling into it immediately. Near the surface, the effect might feel like powerful wind moving toward the opening. Deeper down, the falling air would accelerate, collide, compress, and heat. Pressure would rise rapidly. The tunnel would stop behaving like an empty shaft and start behaving like a planetary scale compression chamber. You would be falling through an atmosphere becoming denser and hotter beneath you. Air resistance would eventually prevent the clean 38-minute journey. Instead of passing through the center at tremendous speed, you would lose energy and settle somewhere near the middle. But you would never reach that point alive. The air alone would become crushingly dense and hot long before you approach the core. And then, the larger problem begins. What surrounds the entrance? If the hole opened on dry land, the atmosphere would continue pouring inward until pressure inside the tunnel began opposing the flow. But if the opening appeared beneath an ocean, or if spreading fractures allowed seawater to reach it, the ocean would begin falling too. At first, water would race into the shaft under gravity. As it descended, increasing pressure could keep some of it liquid at temperatures far beyond the boiling point at the surface. Farther down, however, the heat would become overwhelming. Water would flash into steam, mixed with compressed gases, react with hot rock, and add even more pressure to the tunnel. The opening would become a violent circulation system carrying water and air deep into the planet while forcing superheated gases and debris back toward the surface. The hole would not quietly drain the oceans through Earth like water through a pipe. The falling material would collide with rising pressure, collapsing rock, steam, and molten material. Around the entrance, the surface could fracture as unsupported rock failed and the opening widened. Earthquakes would spread through the region, landslides would pour into the shaft. If the opening touched the sea, coastal water would continue surging toward it. But Earth would not swallow the entire ocean. The tunnel would likely choke itself. Rock, molten material, collapsed crust, sediment, water, and compressed gas would eventually clog the opening or destroy the conditions keeping it open. The planet would close the wound because gravity and pressure leave no stable way for an empty passage to exist through its interior. That leads to the stranger part of the thought experiment. A hole through Earth is usually presented as a question around falling. Would you come out the other side? Would you float at the center? How fast would you move? But a real opening would not be a transportation system. It would become a path through which Earth's surface begins falling into its own interior. Air, water, buildings, soil, and broken rock would all be pulled toward the same opening. And while we imagine ourselves falling through the planet would already be working to erase the hole behind us. You would never reach the opposite side. There may not even be a tunnel left by the time you reach the first few kilometers, because the deeper truth is that Earth is not a hollow object waiting to be crossed. It is a world held together by the weight of everything pressing inward. Opening a path through it would not reveal an empty route to the other side. It would give the planet somewhere new to collapse.